Hey guys, what's up? Eddie Aho here with KissAnalog.com. Last video we did an introduction to Spice. Kind of talked about where Spice came from, Berkeley Spice, Berkeley University, and talked about how we get that into a simulation. And today what we're going to do is show how it's actually done in MicroCap. So how Spice meets MicroCap. So first I just want to go over a couple of things, some background stuff. I don't want to go over too much depth in the background stuff, like totally covering all the functions and all the parameters and all the things with Spice, Berkeley Spice, and how, and all the things with MicroCap. I mean, that's just a gigantic subject. So what we want to do is know enough that we can jump into it and kind of understand what we're doing, so we can start playing around and learn as we go, right? That's the more fun way to do it, and that's the KISS method. So we'll keep it simple, right? All right, so let's go over my last board. Start with that. All right, so this is where we kind of left off, this board here. I kind of added this description here, and the last video I ended up numbering it U106, KISS U106. So just barely started that playlist. There's only 6 videos now in it, and we're going to include this one. This will be KISS U107. Okay, but what we did is we talked about how you have to draw up a schematic. In the old days, before you had these cool tools like MicroCap and these other things like Intusoft, PSpice, where basically there's an interface where you draw a schematic and you do all things at a high level, making it a lot easier, so you don't have to write out lists like this. But it is nice to understand that this is how it was done, and this is what those programs are doing for you, because you'll see this as I pull up MicroCap and I show you, the schematic basically. We'll probably even start off something simpler. Maybe just resistors to start with, okay? So look at what we have. We have elements. We have this element here. We have 3 elements in our circuit. Pretty simple things. A voltage source, and it's called an independent voltage source because it doesn't depend on anything. In this case, it's a 12-volt battery. It's a DC voltage source. And you could have an AC voltage source. You could have a current source. And they could all be independent. You set it up for, say, 1 amp current source, and that's what you get. And then there's the dependent ones. And I just want to remind you of that. The dependent ones, they become usually part of models and stuff where you have gain. And we'll talk about that later. But just want to throw it out there so when we see it, you'll see that there is a difference. And just an introduction, right? So then we have a resistor, and in this case it's a mega ohm. Now when we enter these parts into our MicroCap, we just write 1 capital M, 1 micro U, that kind of thing. So we'll show you that in MicroCap. But we have 3 elements, and then we have these nodes, right? And we list them in our circuit when we describe our circuit, but we don't have to do it this way anymore because that's what MicroCap does for us. But understanding that MicroCap, that's what it does, is it says this is between node 1 and the datum point, which is node 0, and this resistor is between nodes 1 and 2, and the capacitor is between 2 and datum 0. Okay? And it's a 1. So then you put your value here. Then the syntax allows you to put different things, along here to describe things like, say, temperature for resistor maybe, or things like that. But we're going to keep this simple. We're not going to do all that. But understanding that you can put those things in, and I'll show you in MicroCap how that's kind of done. Okay? So there we go. The important thing is we have our elements. These are simple elements. This one starts with a V for voltage source, R for resistor, and C for capacitor. And, okay. So, and then we also have to have a reference point, a 0 in our schematic somewhere, so that when we describe our circuit, there's always a reference point, okay? Doesn't matter where you put it really. It matters to you and your schematic and your circuit and your understanding of the circuit, but to the program, it just wants to have one in there somewhere. Okay, now let me just talk about a little bit more. All right, so I just added a few things right here. What I wanted explain is that once you've described your schematic, writing this net list or this nodal list, then that's your schematic written down in some kind of list format, and the program, the SPICE program, is going to suck that in, and then it knows what your schematic looks like. Well, then it says, well, now what do we do? So you say, well, I want to do a DC analysis. So then at the end of this statement, you would put, say, DC, and you go, I want to start from 0 volts and go to 12 volts. And I want to do that in 1 volt increments. And then you'd say, well, but I want to see what's happening. So plot that, and I want to plot V2, and that would be node 2. So I want to plot this point right here. So I say, okay, then plot that point out. And then you say, well, I also want to plot the current through R1. You want to go current through this node because, you know, even though that's a wire, you could select a wire, but it doesn't allow you to do that. You have to select a component, okay? Now, in MicroCap, it's a lot simpler. You draw your schematic, remembering to put a ground in there, remembering to name things properly. Once you've done that, you set up your voltage source, and then after that, you go into your simulation tool and you set up the simulation, and you say, kind of like this. You say, well, I want to go from 0 to 12 volts in 1 volt increments. And then when you say plot V2, you're going to say, especially let's say we're doing an AC analysis and you want to go from 0 hertz to 100 kilohertz. You'd go 0 hertz to 100 kilohertz. And then you'd say, and how many steps should I take? You know, should the program just do 0 hertz and 100 kilohertz and plot those 2 points? You'd say, plus, you know, I want 10 points in between. So it'd go 10 points in between. You could say 1,000,000 points, it'd just take a long time. But so just understanding that that's what we're going to be looking at when we go look at MicroCap. Okay, we're going to pull up the program and I'm going to show you that. One of the things I want to explain about MicroCap is when you want to plot these things that you want to look at, you can set it all up that way. Let's say you go transient analysis and you say, I want to look at this voltage or this current over this frequency band with this many data points. Okay, well, one of the cool things that happened with MicroCap and Intusoft, and I think PSpice did it too, is they also, once you run the program and it runs through all this stuff and it plots and prints out all this stuff, well, there's also another mode that you can go into. You can say, just do this, do the analysis part, and then give me basically like a scope, give me a graph, and then I'm going to go use my probe and I'm going to probe the points that I want you to plot. So that's interactive. Instead of setting it all up and then hitting a button saying go, it allows you to have some, you know, to interact with it. You can run the simulation, and then afterwards you can go, okay, I want to, with your little voltage probe, you can go, I want to see this voltage, I want to see that voltage. And you can just go click on things and it'll draw them for you, okay? Then you say, I want to see this current, so you switch over to current. Now here's the thing with that tool, with a lot of the tools, is they'll run the simulation, but if they don't know you want to look at voltage and current, both, they'll typically just do the voltage. Once you set it up and say, no, I want everything, I want voltage and current, well, usually there's a power thing in there too, so it'll plot, when it does all the math, it'll capture the current, the voltage, and the power for everything in the circuit, and then when you go click on things, it just, you know, plots it for you. So that's kind of how it works. That's why in MicroCap what we'll see is there's 2 different transient analysis. One is for the probing and one is for the pre-setup. The pre-setup has advantages because you can set up different graphs with different XY axes, and you can have all that set up for you so that when you run your analysis, it plots it the way you want it to be. And then when you change something, you can get a new plot and change it the way you want it to look. In the probing, every time you probe, it's going to auto scale things. It's going to redraw the plots for you, and then you kind of have to stretch them out and change them, you know. But there is that advantage where it's quicker and easier because you don't have to set it all up, and you can just randomly go around, you know, looking at voltage and currents, trying to understand your circuit without having to set it up to begin with. Once you've probed it sometimes, that's when maybe you take the trouble to go into the other place to do transient analysis, where you can set them all up, and then you can just say go and let it do it all for you. Okay, so I just want to explain there is two different ways to do it, and that's why. So the interactive probing technique was something that came along later, and it's just kind of a cool feature, right? And it makes it simpler to start with too, I think, maybe. But things are happening without maybe understanding what's going on in the background. And another point I want to make is when we go look at MicroCap, there's several different ways to do the same thing. So don't get confused if one time you see me, for instance, let's say we type an R on the keyboard, a resistor will pop up and we can drop a resistor down. Or you can copy and paste a resistor. Or you can go to a library and pull down a resistor. There's all kinds of different ways you can do that. And so I'll mix it up so you can see the different ways. I just don't want you to get confused, like, hey, I thought you did it this way. Now you're showing, you know, like, which way do I do it? Take your choice. Do it the way you want to do it. Experiment. Have a little fun. See how it works. And I just want to explain that so that it doesn't confuse you when you see it, okay? Okay, there's one more thing before we go look at MicroCap. Alright guys, so you can see I changed the number to Kiss U107. Now, what I want to do is I want to explain, we're going to do this circuit in MicroCap. And I just want to show you a few things about this. What I did is I have the V, the things in red, the R's, those are what's important in the MicroCap or the, you know, the SPICE program to understand this is a resistor, and then it's going to look for a value after that, okay? But the 1 or the 2 or the 3, doesn't matter what those are as long as they're different from each other, okay? Just want to explain that in case you want to call this load 1, R load 2, R load, you know, or RX or something like that. Now the voltage source might have a circle, might look different than say a battery, but also one of the big questions is, you know, when you do a simulation, what are you doing? Basically, you're kind of replacing what you do on a bench test. Instead of going to a bench, you build it up on a computer model and you let the computer tell you what the bench is going to tell you. Well, you know, the obvious question is, well, how accurate is that? Well, it's only as accurate as you build the schematic, okay? You go, well, yeah, but if I got all my resistors, all my capacitors, I got my transistors, I got everything in the circuit, so what's different? Well, you know, when you build something on the bench, these connections are wires, right? And you have a voltage source. It's not this, you know, these are what we call ideal parts. That's resistor. Ideally, that's resistor. I showed a capacitor over here. So just to show you, a capacitor is not, the ideal capacitor is just, you know, just two blades, right? But when you look what's inside a capacitor, you have a ESR, an equivalent series resistance, right? You also have some inductance from the leads. Even surface mount, you're going to have some inductance. And then you also have internal to the capacitor, you'll have some inductance, and more or less depending on the type of capacitor, right? And then you have this leakage resistor that wraps itself around. So this is kind of, you know, when we talked about levels of models in the last video, this is going into that deeper level. Instead of treating it like an ideal part, but like a resistor, for instance, it's also going to have some inductance, right? We call some resistors non-inductive resistors, even though we call them non-inductive, there's still some inductance, but much less compared to, you know, what they would have otherwise. Anyway, as parts, you know, as we enter transistors and all those other things, they get very complex, and there's lots of parameters you can take into account, and that's when those levels come into place. And so when you simulate a circuit, something simple like this, and then you go to the bench and you go, wow, why didn't that work? I have a 0.1 ohm, a 0.1 ohm, a 3.1 ohms, and I put 120 volts on there, and my simulation showed I had, what is that? You know, that's a whole bunch of current, right? And you're like, I never got that. Well, that's because my power supply is only good for 3 amps. I mean, that's real world, right? So really, this voltage source, it has some internal impedance in it, and it can only put out so much current. So it's got a current limit, plus it's got a source impedance limit to it. So that's another real life example. So you have to, you know, consider those things. Often when you put a voltage source, you might just start off with that, knowing that you have some resistance. Maybe these are K ohms, and you don't care if there's a couple, you know, 100 milliohms or something like that. But then in another circuit, the one I had before where we had a capacitor and we're trying to charge it, maybe we do care about that. So sometimes you do care, sometimes you don't. Understanding your circuit and how it works, understanding the parasitics and where they come from and which ones matter at a certain time, which ones don't. Sometimes you get surprised. You go, ah, geez, I didn't realize that inductance or the capacitance was going to throw me off. So that's why sometimes the bench you know, work looks different than simulation. You know, where really the work comes in is once you do the simulation, is maybe putting in some of those parasitics and see what happens to your circuit. When you go to do the bench test, see what that signal looks like, and if it doesn't look like what's in your simulation, then try to make a match up. Try to add the parasitics to the schematic that you left off, and you go, okay, now it's working. Okay, good. And the advantage of the simulation is it's very easy to change values of things and go around and play around and look at a bunch of different things. A lot of times that's a lot easier than going to the bench and taking all those measurements. And a lot of times it helps you before you get into the bench to already understand your circuit. So if you see a problem, you can fix that before you ever get to your bench. Okay, let's go look at MicroCap now. All right, so let's go ahead and open up MicroCap 64-bit. Here's our tip of the day. And of course, we could turn that tip of the day off, but I like to leave it on just as reminders of things that maybe I've forgotten or things I don't know. Okay, so right now it comes up with wanting to place resistors. So since I'm going to place this circuit, I'm going to say, okay, let's go ahead and do it. And then it comes up with this. Now, when I type in the value, I'm going to just put, let's say, 100 ohms. Now, I could come down here and add different parts of this model, and as I hover over them down here in the description box, it tells me what these things do. And by the way, the smoke feature is a cool feature we'll look at someday, but yeah, so you can just put in information here, and over here on the right you can see some of these things will pop up as we go down. Now, what I can do also is I can look for parts here. I can come down and select a part, and you see down here at the bottom all this information. So this is when you start getting to a deeper level of a model. And as I hover over these things, see temperature measured down here, it shows me those things. So you know, I can come down here and here, let's just scroll down, look at the different resistors. So these are different resistor types. And I could just say, well, I'm going to choose a RN part. Okay, maybe I'll just choose this one for fun. Okay, then I go ahead and hit place, and it places it. Now, I'm going to place another resistor. I could just click right here and place it again. One quick thing to do is, let's say if you're going to use this 100 ohm resistor in multiple places, you can copy and paste that in different places. That's another way of doing it. The copy command is up here in edit. You can come here to edit, copy. Okay, so what I'm going to do is I'm going to come up here and choose my arrow so I can get out of that automatic place thing. And by the way, there's a setting in your options where you can, once you place a part, it'll automatically go to your arrow, or you can leave it in that place mode. And again, down here at the bottom you can see select modes, your status bar. So it kind of tells you what you're doing. Okay, now I want to show you another way. Go to component and go to primitive. These are just like what it sounds like, primitive parts. They're not parts you find with, here, let's just show you an active device. So NPN transistor. So it just comes up with the NPN, PNP, comes up with your basic parts, okay? Your basic models, where this analog library comes down to BJTs, and you come over here and you come up with actual part numbers from vendors. Okay, so that's the difference between these two things. And then you got digital libraries too, and then there's things you can animate, LEDs, switches, and things like that. And that's for another video. I'll talk to you about that another time. And then down here are some commonly used parts, and you can just come down here and select a resistor that way. So I'm going to come up here to primitive so I can show you where they are. So you come over here and say, okay, I just want a resistor, just basic resistor. So I'm going to place that right here in series, and I'm going to call that 100 ohm too. I'm just going to leave that value. See, it automatically came with my last value there. I'm going to say, okay, I'm going to keep that. See, another thing, you notice this first one is R1, this one's R2, so it's naming them for me too. Now I can go change those names if I want, but here, let's go choose another resistor. I'm going to show you another way. Go back to my select arrow, and see, I'm just going to hit my keyboard, my R, and there's resistor. Okay, now I want to rotate this one. So I come over here and I can flip them. This is kind of a vertical flip or a horizontal flip, and this is a rotate. Whoops, sorry. It rotated the one that's highlighted. So I'm going to rotate that all the way around. Okay, and you notice how it changes these reference designators, how it moves them around when it rotates it. Okay, what I need to do is I need to place this guy, and I'm going to call him a 200 ohm. I'll show you why. So I'm going to call him 200 ohm, and then I want him to rotate, and I'm going to rotate him like that, so the reference designator and the part value are next to the part. Okay, so I'll move him later. Right now I'm just going to place another one, and I'm going to go back to calling it a 100 ohm. We're going to have a little fun here. I'm going to explain something here, do some explaining. Okay, let's move this guy around. Oh, okay, that's where we want it. And then this time I'm going to go back to my arrow. I could just place another one, but just for fun I'm going to show you I can do that, and then right click or double click or however you do it on your machine, and copy, and then I'll come down here and I click where I want to place the part. So I click right underneath them, and I double click again, and I say paste. See, R4, R5. So just different ways to do the same thing. Now I don't want to I want to have some space. I want to put these in series, but I want a wire between them. I don't want to just put them butt to butt, okay? But what I'm going to do is I'm going to connect them right there for a minute, because I want to show you something. Look at that. It automatically connects a wire when I do that. Okay, now if I click on the wire, you can see the wire highlighted. So I have a little distance between the wire. I like that. So I'm going to take this guy and I'm going to place him kind of in the middle. And I'm going to grab this wire right here. And I'm going to click on here and then just hold the mouse button down and drag it. And I'm going to just drag it right about here. And I'll connect that later. So I want to connect this guy to that. And see what I'm going to do is I'm going to end up putting, okay, now what I do is I purposely drag him down before I turn this way, just like this one. And the reason why, here I'm going to go back to my arrow. Then I can grab this piece of wire and move it this way. If I just put it right up on top of the resistor lead right there, I wouldn't have a wire to grab. I'd have to grab the resistor. So now I can pull this down and I can pull it this way. So like I say, different ways to do the same thing. Okay, now I could grab my wire and go back and put a wire there, right? Or I could drag him down, let him touch that wire, and then he'll hook onto it. And see how he's pulling this wire up? I'm going to come down here and pull this wire away from him. Okay, now that he's not connected to that bottom wire, now he's free to move around like this. Now all this stuff I'm doing, it's like rubber bands, remember? In other videos I've talked about this. I repeat these things so in case you haven't seen videos or just to kind of drill it in. But this icon right here, if I turn that off, now if I grab him and pull him, he just breaks loose. He cuts loose. So sometimes I want that. Sometimes I want rubber banding. So if I click that back on, now he's rubber banding. Okay. So that's what I want. So now these guys are in parallel. So these two guys are in series, and these two guys are in parallel with this guy, right? So you see why I got two 100 ohms, add them together, they're in series. It's just like a continuation of one resistor. So it's 200 ohms in parallel with 200 ohms. Two 200 ohms in parallel is just, if you have parallel resistors, same value, you just take the value, divide it by how many parallel resistors. So we pretend this is one resistor, that's 200 ohms, and another 200 ohms. So we have two 200 ohms divided by 2 is 100 ohms. So this is equivalent to 100 ohms, which is equivalent to this guy. I'm going to drag him, hook him up to that wire. See, now when I move him, he's connected to that wire. I'll just bring more here, tighten up the circuit a little bit. Okay, and then I can bring this guy down, and you know what I'm going to do? I'm going to rotate him. We're doing a little teaching class here on series parallel circuits. Now, once I connect him here, I'll connect him here, pull him out, stretch him down, stretch that up. Okay, and then I can bring him all the way down here and connect to this guy, and then bring him back out this way. I can just connect with wires. I'm just showing you how you can do it this way, just how the rubber banding works. Okay, so now I have all those connected, and what I'm going to do is I want to show you how you can change the value of this part. Okay, now remember, this is equivalent to 100 ohms right now, and then I have another 100 ohms, that's 200 ohms. So this 200 ohms is an equivalent parallel resistor to this 100. So I'm going to make this guy 200, and then we're back to a total of 100 ohms here in this circuit. Let's get a battery source. See this little stretch of windows right across here? This is another way you can grab parts. I have capacitors, resistors, and I have voltage sources too. Look, there's a battery right there, and here's some of these voltage sources here. So I can grab either one. It doesn't matter. It's the same thing. If I click on this arrow, it shows me I can choose these instead of rotating it. I can just grab it the way it is right now, and I can do it this way. Okay. Now I can make this a 12-volt battery. Okay. Come over here to arrow, and come over here to my wire right here. Now the difference between these two things is this wire right here. Here, I'll just show you. If I connect to that wire, I can do diagonals. You know, if I want to do it that way, I can do it that way. But normally you want straight edges, right? So I'm going to come over here to my arrow. I don't have to replace them. I can just stretch them like that and grab the corners and make them straight again. So I'll bring this all the way down. I grab this corner and bring it up here. Whoops, now I got this extra one, so I could cut him loose. So I'm not doing things the easiest way. I'm just showing you different ways to do things so you can see. Now when I connect this battery, you see I've got these other things I can make this so it's not ideal, right? And I want to show you something else. You know, instead of making it 12 volts, now remember I have 100 ohms. Let's make this 100 volts. Now I clicked on it that way. I could have just clicked on the symbol, see the symbol right here, and typed it in here. But if I click down here somewhere so it's not highlighted, and then I just click on that and then double click on it, then I can just change the value there instead of going into the other menu. And I can also change this if I want. I can call it VN. Okay. All right, so 200 ohms in parallel to 200 ohms gives 100 ohms. That in series with another 100 ohms is 200 ohms again. That 200 ohms is all in parallel to this 200, so we're back to 100 ohms. A voltage source of 100 volts tied to 100 ohms is going to be 1 amp of current, right? Okay, let's just go to analysis. So I can come up here to analysis. Now you notice right below it's transient, AC, DC, and then some other stuff. But see down here, these 3 probes, they're basically duplicates of these, but they're different because with the word probe in front, that means I can interactively probe once I run the analysis. So the difference is, here, I'm going to go ahead and click on this. I don't have, oh, look at this. Here we go. Look at this error command down here. My schematic right there does not have a ground. So I need to put a ground so it knows where the zero datum, it knows where the zero reference point is. And here, we don't want that thing, so we'll do this undo button right here and hit the arrow, back to select mode. Now let's go to analysis. Okay, we'll go to transient analysis, and look at that. We don't know what transient analysis it ran because we didn't set up anything, but let's just go click on it and see what happens. So that should be 100 volts, right? Because this is an ideal 100 volts. This is like a mega generator. It can put out 100 volts at however many amps we need, because it's ideal right now. See the straight line? 100 volts. Look, it ran for 1 microsecond. Okay, let's go up here and see under probe, there's the run command. That's to run another simulation. There's a limits and there's a stepping. These things come in play a lot, so we want to go limits. Let's see what our limit was set to. Look, maximum runtime 1 microsecond. Let's make that 1 millisecond. And start time, we're going to start at 0 time recording. And we're running this at 27C. So, and then we'll talk about these state variables later and all this stuff, but for now we're just gonna not worry about that, okay? There's, that stepping thing I showed you up in that menu. Here it is again. If I click on it there, it comes up with the stepping window. So we're gonna say, okay, we don't care about that right now. Now, up here in probe, it said run. There's also a run button right here. Again, there's many ways to do the same thing. So sometimes it can be confusing because you're like, whoa, what's the difference of this and that? And, there's no difference between some of these things. It's just different ways to do it. Makes, might be easier to do something one way one time and another way another time. Okay, now, you know what? We can see that our probe is selected up here in this corner, and we're an interactive probe setup. So I can come over here and I can say, well, let's look on the other side of this guy. Oh, look at that, 50 volts. Remember, it's voltage dividers because I set up those resistors so that everything is halved every time. So if I come over here, look at that, another half. So we drop down 50 and then drop down 25 because of the way we doubled up these resistors, and we have the impedance every time. So yeah, so there's our voltages at each one of these nodes. Now, if we want to see what those node numbers are, like that nodal list that we were talking about, what we do is we come up here and we click on this guy right here. See, and if I hover over it before I click, it just tells me what it is, node numbers. So I click on it, see my node. So it numbered this node. See, if I hover over it, it highlights that whole node. And meanwhile, you see that artifact right there, I can delete that. It's just a piece of wire hanging off there. But yeah, node 2, it's all that stuff. It connects all these elements together. And then here's a node. This node only has 2 things connected. And then this is our 0 node. See the node name down there? 0, node name 0. So yeah, we have 3 nodes plus our 0 node. Okay, so there's our voltages, right? Let's add our current. Let's go vertical and come down here. And see, right here is our probe. This sets up our probe, but this vertical thing, there's a horizontal one too, but there's a vertical one is where we find if we want to probe voltage or current or these other things. So let's go to current. Now current is through devices, right? Not at nodes. It's through devices. So let's look at the current out of the voltage source. Now it put it down here. It's hard to see because these things are scaled. This is 100. See, if I hover over there, it kind of shows me that. See down here at the bottom? Right down here, it shows blue was node 1, voltage 2, voltage 3, and then this is current and VN. Now, if I click on this VN again, you notice that went away? So that's how you toggle things on and off. Another way you can do is go up to probe and say delete curves. If I say delete curves, it comes up with these. So I can click on one of these and say, okay, delete that guy. Or I can say, no, I want to delete all my voltages. So let's delete all curves. Okay, now let's go back over here and measure currents. Okay, there's my current. Now look at that, it's -1. And that's because the current is going around this way, but it comes back to here. So it's the current coming back in. So it's talking about the negative current re-entering it. Now, if I come up here, look, there's -0.5. Okay, so that showed me a -0.5. Well, that's weird, right? Because this is plus, so current should be going this way. Okay, well, let's just continue. Let's look at the current of this guy. Where did he show up? He's red. He's -0.52. So, what the heck? All right, so let's go down to this guy. Okay, this guy is right here. It's like -0.25 because half the current went this way, right? So, and this is giving me the same current in this guy. Okay, yeah, so see down here, this IR4, that last current we looked at, it's right there. So now if I click on this R5, it's gonna be the same current just going through R4, and it should lay right on top of it. So click on that, and it did. Look, it just covered it up. The black one, IR4. Here, now let me show you something. I wanted to make a point here because this is important when you're looking at currents. There's conventional flow and electron flow, right? And we like to think positive goes this way. We like to follow positive current because it just makes it easier to read schematics that way, I think. And so here, we got our arrow chosen. Let's come over here and turn off rubber banding. And now we have our node numbers on. If I grab this guy and pull him away, see how that node 2 is on this side and node 3 is on this side? These nodes are connected just to this resistor, nothing else, because he's not connected right now, right? Well, see, current flows into the lowest number and out of the biggest number. So when I read current, it's going this way, and so it's negative because it's going from the big number to the small number. So what I do is come over here and flip it that way. So this is something when you start putting your circuit together, is come up here and turn on these node numbers so that when you're looking at your parts, you can see their node numbers. And I go, oh, 3 and 4, that's not what I want. Now, you know, when I rotated it around, again, more ways to do, see what happens is it puts this stuff all the way down here. Now I could click on here and just drag it up there. I'll do it with this one on this guy. Okay, see now 3 and 4. So that's the way we want the current to go. And then this guy here, 5 and 4. So let's flip it that time. See, when we flipped it, now one thing, if you look really close, see how it zigzags? This one zigs to the right and then across this way. Now this one zigzags the other way because we flipped it. So, and also put the R on the bottom. I like my R's on top, so that's one problem with doing it that way. And rotating it, moving it, ends up kind of the way I like to see them, actually. So yeah, when we move all these things, look, they're all upside down and backwards. And that's because when I put them in, I was kind of doing that on purpose just to make a point here. Because when you're simulating a circuit and things don't make sense to you, it's good to know that if you think, well, there might be a circuit that's not obvious like this, that the current just seems backwards to you. And once you analyze the circuit, once you figure it out, once you simulate it, you see the current looks backwards. And if you pull the part away, now transistor is more obvious, right? But a two-leaded part like a capacitor resistor might not be obvious. And once you pull it away, you go, ah, that's what it is. I thought the current was flowing this way, so I put my part in a certain way, and it turns out it's going the other way. So anyway, now let's run that same simulation again. Probe transient. Okay, let's go look at currents. Okay, now the voltage source, same thing as I said before. All these other currents are going this way, but then they come back in this way. So they're kind of going, on this voltage source, it's going the opposite of everything else, right? And that's what we call Kirchhoff's voltage law or current law. So all currents leaving a node are equal to the currents going into the node. Okay, now let's click on that guy. Okay, there we go. Look at that, a plus ½ amp. Okay, what do you think we're going to get here? The other ½ amp. Yep, landed right on top. So see, here's our currents down here. We got both these guys on top. So the current coming into node is equal to the current going out of the node, right? So here you go. Here's -1 and here's two half ones. So they subtract and they show the Kirchhoff's law is true. Okay, now the ½ amp went this way, and these 200 ohms are equal to this 200, so it's going to split again, right? So there's our quarter, and then over here there's our other quarter, just landed on top, and then click here, and there we go. There's our currents. So there's our kind of getting around the circuit, building the circuit from scratch, and seeing how these things work. So hope that helped, and it just takes practice playing with these menus and getting around, and so I tried to show different ways to do the same thing. Now this interactive menu, what's interesting about this, here I'll hit the arrow, you can come and actually change your value in the interaction. Look, I'm going to change this to 500 volts. Well, heck, let's make 1,000. Now once I click it, all the currents automatically change. So now the currents are off screen. I have to zoom out so I can see them. Okay, and then I can zoom back in on just those currents I see. And yeah, and as you select these different values down here, you can come up here, and when they're laying on top of each other, it's real hard to see, obviously. But you can click these things, it shows the data points that it took. That's how many points it took. So you can hit these different things so you can see, you can see that down here, the map here, it shows you what data point goes with what. All right, so this is just a quick introduction and a quick just with more and more practice, we're going to learn more and more about this. Now, one thing I didn't explain is this is your working window. Okay, I did a video on this when I talked about MicroCap being free. I suggest going back to that. I kind of talked about all this stuff too, but this is your working window. Here's the tabs of your working window. You switch around these tabs. Yeah, so this is just your tabs, your working window. And if you have more than one schematic open, you got these arrows down here to kind of jog through them. Also see this tab right here. This is the name of this circuit. There'll be more of them across here if you have more open. And then down here's your status window. This bar, you saw that error command once before. You see the status bar here, select mode. It shows me what mode I'm in, this bottom corner. But yeah, so it just takes a little while to learn this. I recommend going back and looking at that very first video I did. I kind of walked through MicroCap that time and talked more about this GUI, this interface. Okay, so if you want to save this circuit, you can go up here and say save as, and then say, okay, I'm going to just, you can call it whatever you want. Okay. And now it's saved. Now if you look down here, you'll see it right here. And if you look up here, you'll see the file, the directory that's stored in. And you see the MicroCap version, all that. Now again, just to remind you guys, go down here to your check for updates. Make sure you check this, check all these guys, so that it'll check for updates for you. I'm all updated, so I'll just close that. But yeah, all right guys, hope that was helpful. All right, well I hope that helped a little bit, introduce you to how to use the program. Now go back and watch that first video I did when I said MicroCap was free. The link's down below. There's a playlist below too that has the videos in it. Okay, and now in this video what I did is I showed the transient, the probe transient, because I wanted to show how fluid or how easy it is to start to use. The next video I'm going to show the transient, the first statement up above, and that's where you set it up so that, let's say that, you know, once you've gotten familiar with your circuit and you know what you want to look at, then you can set it up the way I'm going to show you in the next video. That way, every time you hit it, you don't have to resize windows and that. It'll just display it the way you like it, okay? And I think we'll do an RC filter. I think what we'll also do, well, I don't know, we'll see. I think we're going to do a thing where we do an impulse into a capacitor and watch the capacitor charge so you can see how it follows the equations, okay? But, all right, I hope you liked it, and I want to thank the Patreons for all the support and everybody for watching the videos and supporting me. And I appreciate that. Leave your comments, and I really like the comments and the communication between viewers below. That's really awesome. So, hope to see more. Okay? All right, thanks guys. We'll see you next time.